Hey guys, welcome back to the shop. So several videos ago, I was doing a review or showing showing how my old South Bend lathe, how I tied in controls for the VFD for start and stop, forward and reverse, jog button, speed control, and so on, and a e-stop. I don't have any power on it right now. But a few people expressed interest in how to go about wiring that kind of stuff up to a VFD. So we'll take a look at that. I'm probably going to go real slow, step by step, so hopefully it's not too boring. And I'll put in some chapters so that you guys can jump ahead or fast forward ahead to get... Yeah, we installed, repaired, replaced, serviced literally hundreds of VFD drives in the HVAC industry, and I worked on them almost every day for 44 years when I was working. Thankfully retired now and just hanging out here in the shop. So, but anyways, I still don't consider myself an expert on them because there's just so much to know about them. And the HVAC industry only uses a small, well, maybe 50% of the capability of the VFDs or VFD applications. So there's a lot of settings and ways to use them that we never used in our industry. So bear that in mind. I've got a couple VFDs over at the bench. One is an old one, which I think will be pretty similar to the current import versions, which are pretty basic. So let's go to the bench and let's get started. I got a couple of used commercial VFDs here that we can use. This one's an old Toshiba. It's about 30 years old, but the wiring is still very similar to what you would see on an import, the Chinese drives, and the programming I think would also be quite similar. And then this one is a newer Danfoss Drive. It's been rebranded. I really don't want to show the brand. I used to work for that company. So anyways, let's take a quick look at this motor. So this is actually a very high quality motor. It's an ABB and it's a 1 horsepower. It's a C-face type mounting. There's no feet on the bottom. It's of course used, and here's the reason I got it. Take a listen. I'm not sure, but I think the bearings might be bad. But it'll be okay for what we need to test. Someday I'm going to put new bearings in this when I find a use for it. Right now I don't have anything planned for this motor. Let's take a minute and talk about some of the switches that you might be using to control your VFD. When I was getting ready to make this video, I wasn't sure what I had, so I just went on eBay and ordered some cheap ones just to have something for examples. So the first thing you're going to want to do is figure out how you're going to start and stop your VFD or your machine. Yeah. And in most cases, if it's a lathe or a mill, you want forward and reverse. Okay, so you can get these rotary type switches that have 3 positions. Okay, so center being off, and then forward, reverse, or the other way around if that's your preference. Okay. And the way these work, this particular one, there's actually 2 sets of contacts, and right now they're both open. You can see these little green indicators are down. If I rotate to one position, only one of them turns on. Okay, so in this case, we would use this side for forward, and of course center is off, and then this side would be reverse. Okay. And then I got several other examples. Here's this is a higher quality switch. I think this is a IDAC is the brand. Exactly the same function. 2 normally open sets of contacts, 3 position. These can come in a variety of configurations, the way they do the cams and so forth in here. You could have both of them turn on at the same time. You can get cams that'll do that. They can have multiple positions, more than just the 3 or the 2. So what you want to look for is a 3 position. Okay. Here's another brand that I don't know what brand this is, but same function. I kind of like this style because it has this release, so you can remove the operator for wiring. So if that was installed in a panel, that would stay in the panel. You can pull the block off, hook up your wires, and then just snap it back on, and you're good to go. It's kind of a nice feature. And some of them you can get with lights that have a similar situation. The handle will be lighted, and the light goes in from the back, and they usually have some type of release mechanism like that as well. Okay. This is kind of an interesting one. This one came on my South Bend lathe when I first got it, and it's a double pole, double throw switch. Okay, so you go one way, these two make. You go the other way, these two make, and then center position, everything's off. And it's got 2 sets. So for a VFD, you'd only need to use one side. It's kind of an interesting switch because it's spring loaded. When you go to the center, it forces you to stop in the middle, which is actually kind of a neat feature. That's a really old switch. I don't know well, I can barely see the brand there. It doesn't matter, but that's an old school switch right there. This one is a heavy duty industrial type switch. I think it's an Allen Bradley, I'm not sure. But the way the terminal block is laid out here is a little different than these. These are easy to figure out because they're straight across, okay? But this one, this is a pair, and this is a pair. And I had to get the meter out and actually decode it. All right, and then I picked up a momentary push button operator type. And this one, you see we got a green and orange, so we got a normally closed contact. Normally closed contact, normally open contact. So it gives you options on how you want it to perform or what you want it to do when you press the button. We're going to use this for our jog function. I have a feeling we're going to need both of these to be normally open. And what's nice about this style of switches, you can stack your operators and you can switch them around. So what I'll probably do is take one of these off and swap it with this orange one. You can also double stack them, triple stack them, so you can get a lot of different options. Okay, so that one's going to be our jog button. And I think I mentioned I got these on eBay. This was like $6, something like that, and about the same for this one. But they're really low quality, but they work. And then we've got our emergency stop. I bought one and then I realized I already had another one. So they come with this label. You can use it if you want or not. And these are usually maintained. So when you hit the operator, it latches in. And depending on what you're using here, and here again we have a normally closed and a normally open. So in most cases you'd probably be using a normally closed to shut down your VFD in an emergency situation. And we'll get into that when we start showing the wiring. And then to reset these, you got to twist it, right? And it resets. Okay. These, you can pick these up on eBay with the box for like $12. Better than nothing, right? But I would probably recommend getting a more commercially designed switch. But we just got these just for example. Okay, and this is probably the most confusing, I'm thinking, for everybody, is how to rig up a remote control speed knob for your VFD. Okay, And what you need is a potentiometer, and these come in a ton of varieties. This one happens to be a 1000 ohm or 1K. The wattage rating is not going to be that critical. I'm guessing this is maybe a half watt rated, something like that. And what you want to look for is a linear taper on the potentiometer. Okay, what that means is it's a linear change in resistance as you go through the full range of travel. Okay. Now they have what's also called an audio taper, and this one here is an audio taper. And it also has a switch. So remember the old transistor radios where you actually turned on the volume control, that turned it on, and then this was your volume control. Okay. So the audio taper, the resistance value starting from 0 changes very gradually at the beginning, and then as you travel more toward the end, the resistance changes faster. It would work, it just wouldn't be very consistent as you're trying to adjust your speed. Okay, but it might be better than nothing. Okay, the ideal, at least in my opinion, the ideal potentiometer to get is a 5000 ohm, 5K, and that's what these are. I actually bought these because I didn't know I had that one. It's here again on eBay. I think these were like $3 each. These are pretty cheap ones. But you can get them different length shafts, different wattage ratings, and of course different ohm ratings. But just remember 5K is probably your best size to get. Okay. Then of course you get all different kinds of knobs. A lot of them have long shafts like this. You can cut them off. Just hold it by the shaft in a vise when you're cutting, not by this side. Okay. And here you can see I've already put some leads on here so that we can use it for testing. Okay, let's move on. Let's have a look under the hood here. We got the cover off. So this is pretty typical, although on a import VFD everything's going to be real small and it's crunched together. But all your high voltage connections are down here at the bottom. All your low voltage control connections are up here. This actually has a data port. This is an old drive, like I mentioned, so the keypad is not removable. It's part of the housing itself. So we're going to be looking at these guys here. You'll see on a lot of drives there'll be a separate terminal block such as this, and this is a relay. It's a Form C relay, so normally closed, normally open, common. Generally it's pre-configured as an alarm output, but you can usually reprogram it for other functions. These have very good documentation. I didn't print it all out. It's like 100 and some pages. But if we look at our diagram, we have a common connection between all the switches for the forward, reverse, and reset. And that common connection, and it's really hard to see on here, but it's landing on terminal CC, control common. Okay. Our switch is straight through, right? 2 independent switches. So what we want to do is we want to connect these 2 together because we have to use the same common wire to feed both switches. We're using a 3 conductor, and since it's a common, I'm going to use black for the common since it's switching to basically ground. Okay, so I'm going to put black on this side. Okay, so our black is connected to both of our switches. Now we need to determine forward and reverse. So I prefer that way, left-handed, switching toward the left. Actually, that'd be toward the right. Switching toward the right for forward. Okay, so let's use, doesn't really matter which color. We'll use green. Green for go, right? Okay. Put our green wire on that one. I know this is really basic for a lot of you guys, so just feel free to fast forward. But I'm sure there's somebody out there that would like to see every step. Okay, and then when we go to the left, that's going to be our reverse. And there we go, we can see this one made. I mean, process of elimination also, but anyways, we'll put that one on for the reverse. All right, and then the other end, I'm going to actually run it through one of these knockouts. There we go. So black was our common, and on this one it's CC, control common, third one over, right there. Okay, and then we had green for forward, and our very first terminal here is terminal F, and then right next to it is terminal R for reverse. All right, so there is our start-stop control. Let's go ahead and hook power up to this thing, and we'll just make sure that this part's working before we move on to the next step. All right, guys, I've hooked up the high voltage connections here on our drive. Now, the purpose of this video is primarily to show how to hook up the low voltage connections on a typical VFD. Okay, the high voltage part, I mean, this is serious stuff. I mean, this is lethal voltage. If you're not a qualified person and not comfortable working with high voltage, don't do this. Get an electrician, get your electrician buddy to help you out with the high voltage part of it. And absolutely do not touch any terminals while things are energized, okay? And one caution on VFDs, when you turn the power off, unplug or whatever, they retain voltage for quite a while, usually up to possibly 5 minutes. So you want to give it plenty of time for all that voltage to drain down before you touch any terminals, okay? So again, we're here to look at the low voltage side, not necessarily the high voltage side. There's a ton of videos out there that cover how to hook up the high voltage side. But just for FYI, what we've done here, we've got our single phase power coming in. Power's off right now. We're using L1 and L2. This is a 3-phase drive. We're running on single phase. So we're only using the first 2 input terminals. And then we've got our motor hooked up over here to the T1, T2, T3. The European designation is a little different, but you'll have basically the same thing. And then ground is very important. You can't see it in here, but we are grounded to the chassis, and we're grounded to the chassis here for the motor. Motor's grounded when we did the wiring hookup on that as well. Okay. All right. So we've got our switch wired in, ready to go here. Power's off. Let me turn the power on. Let's see if it will run. Oh, let me get it in frame there. Let's see if it'll run in forward. Uh-oh. All right, let's try reverse. Okay. Okay, this is very common on a brand new drive. I'm not sure about the imported drives, but commercial drive, this is pretty much out of the box what's going to happen. It's not going to work, okay? And the reason it's not going to work is they come defaulted for keypad control. So let's try the keypad. Start. Okay, there we go. And stop. Okay, so we need to get the switch operating. And in the configuration for this particular drive, they've got a command mode selection, and I call these hieroglyphics. So we got to get into the programming mode and get to this code, CNOD. Value of 1 is the keypad control. Value of 0 is the terminal block control. So we're going to change that setting. Okay, we'll change that to 0. Enter. Back to normal display mode. There we go. Okay, now let's see what happens. Okay, forward. There we go. Off. Reverse. Okay, so that's a very common thing. You'll have to actually enable the remote terminal connections. I want to hook up our emergency stop or e-stop next. I've already connected up. Now, I've never hooked up an emergency stop on one of these older drives before, so I'm not exactly sure what's going to happen. I believe we're going to have to use the normally open contact on this particular drive. So I've already pre-wired our normally open contact on our e-stop switch. So where do we land it? Okay, if we look at our diagram here, here's our three predefined inputs: forward, reverse, and reset. Okay. They also give us two more, S1 and S2. They really don't show you how to hook them up on here. But if we go to the next page of our manual here, here's the descriptions of what the terminals do. Forward, reverse, okay. And then here's S1 and S2. S1 by default is a control signal input for a preset speed operation, okay, but we can reprogram that. So we're going to use S2, and if terminal is connected with the CC terminal, just like the other ones. Okay, so let me hook that up. All right, we got our wires connected. Let me turn the power on. Now, in order to get this terminal to do what we need to do, I'm in our extended parameters group, IO parameters, okay. These are the hieroglyphic codes, okay. So we're looking for input terminal S1, which is actually, they call that input number 4. Okay, so that is code F114. So let's go there. F group, okay, enter. And we're looking for 114. Okay, enter. Okay, it's currently programmed as number 6. Okay. These are all the possibilities that can be configured for that input, or any of the inputs actually. And right now it's on number 6, which is preset speed selection. Okay, we want to set that up for emergency stop. Oh, there we go, right there, number 11, emergency stop. Okay, so we're going to change that to number 11, or value 11. 11, enter. Okay, and let's go back to our normal display. There we go. All right, let's see what happens. Let's get the drive running. Let's start it up here with our switch. All right, pay no attention to those horribly sounding bearings. All right, we are running. Get you here where you can see everything. Back up a little bit. Okay, let's hit the E-stop and see what happens. Hey, it worked. Okay, and our display is showing E. It's flashing E. All right, that's good. Now, let's see what happens when we reset our E-stop. Okay, it did not restart. That's good. I like that. Okay, so I think what we have to do on this particular drive is you've got to turn it off, and then you hit the stop button. Can you guys see me up here? You hit the stop button on the drive. It says clear. Hit it one more time. There we go. So it requires a manual reset, and that's what you want, preferably. You don't want, in case you're still in an emergency situation or you walked away, you don't want somebody to come up here, hey, why is that off? I'm going to turn that and have the machine just randomly start back up. That was easy. Okay, way easier than I thought it was going to be. A lot of drives don't have a E-stop, but they'll have like a drive enable or a ready to run. You'll just have to poke around. All right, guys, let's look at hooking up our jog button. And like I mentioned before, this is just a momentary contact. Once you let go, it shuts back off, okay? And we're using the normally open set of contacts. All right, so where are we going to land this? We just need to land it on an input. And this time I'm going to use S2. So let me do that real quick. Okay, so we're on S2, and then the other side goes to common. Now this common that we used before, we already had 2 wires on it, but they give you an extra common terminal over here. So it's exactly the same function. We're using input S2, which is input terminal number 5. So that's function 115. So I'm going to go here, I'm going to go to monitor. Right now it's set for value of 7. And what did we want? 4. Okay, here's a forward jog combination. Okay, here's one that's just plain jog. Let's try that one first. So that's setting 4. 4 is jog. So we're going to change that to 4, enter. Okay, done. Now, there's also a setting for what speed the motor will go to in jog. So give me a second here, let me find that. Okay, got it. Okay, so function 260 is the jog run frequency. And the range is 0 to 20 hertz. We're going to set that really low. We're probably going to go 4 hertz. Okay, and then we have the jog stop command. Okay, it's function 261. Stop by deceleration, free running, or DC injection braking. Okay. I think we're going to leave that. No, we're either going to use free running. I don't like stop by deceleration because that may actually take longer to stop that way. You know what? Let's try the injection braking. Okay, let's get to that parameter. All right, let's go to 4 hertz. Basically, you want it to be as slow as you can get it, for obvious reasons, but also with the motor to where the motor will still run smooth. Okay, enter. All right, so our forward and reverse is off. Let's just try the jog button, see what happens. Oh, let's get the motor in frame. There we go. Nothing. So let's try this one down here. Forward plus jog combination, number 18. Okay, let's put that in there. 18, enter. Okay, back to monitor. All right. Okay, here we go. Let's try it. And that injection braking is working pretty good. Watch the motor. That stops right now. I like that. That is really handy on a lathe. On a milling machine, probably not necessary. Now it's time for the speed control, our potentiometer. And by the way, you always need all 3 wires. True, you still can get a variable resistance with just 2 wires, but the impedance input on these input terminal is so low that it would just go right to full speed if you didn't have that other terminal, because it's working as a voltage divider. So on one side of our potentiometer, we've got a 10 volt power source. The other side is a ground, and then the wiper is just sweeping somewhere in between, to give us a variable voltage for the speed. Okay, so luckily this drive actually shows you exactly how to hook up a potentiometer. All right, I got wrapped around the axle there. Let's try that again. Actually, it's easier to see down here. So one side of your potentiometer hooks up to PP, power something, okay? The other side hooks up to CC, and the wiper hooks up to VIB, okay? All right. All right, so trying to determine which way speed increase is going to be when you turn the pot. Generally, you want it to turn clockwise for increasing the speed. So we have a ground wire over here on this side, a hot on this side. Center terminal is the voltage output or the speed output, okay? Now envision a wiper in here. As you turn it, there's actually a wiper that's sweeping around inside here, okay? So if we're all the way counterclockwise, 0 speed, we're closest to this terminal. Actually, it connects to this terminal over here. So we want that to be our lowest voltage, so that would be our ground. And as we turn it this way, that wiper is going to come around like so, and it's going to be working its way toward this terminal, which is our voltage source, our 10-volt source. When it gets all the way over, it's actually it directly connects to here. So we'd have 10 volts coming out of the center terminal. Okay, so the right-hand side would be connected to your ground or your negative side of your power. Okay, hopefully that makes sense. If you get it all hooked up and you crank it this way and it slows down, and you crank it this way and it speeds up, you just have to reverse these two wires. Okay, let me hook this up. All right, we got our power on. Let's go ahead and start the drive. Let me back you guys up just a little bit so you can see what's going on here. There we go. Okay, our forward reverse switch, start it in forward. Okay, we're running. All right, let's try that new speed pot that we just hooked up. Uh-oh. This is probably what's going to happen to most of you when you hook up an external speed control. It's not going to work. All right, so let's stop the drive. Oh, wait a minute. Let's turn it back on for a second. We have a speed pot here on the drive itself. That's currently in control. Boy, those bearings are bad. So setting the frequency command method. All right, so there's 3 choices here. Right now it's using the built-in potentiometer. There's also an option for using the up and down arrows, and then there's an option for using the terminal block remote command. That's what we want. So that's a value of 0, but we have to find this parameter. There it is, FNOD. Hit enter. Has a value of 2. Yep. So we're going to change that to 0. Enter. All right, now let's try it again. All right. There we go, forward. All right, we got our pot working. Now what I'm noticing, it's not going to as low a speed as it did when it was on the keypad here. So there's another parameter to change. Let's stop it. Boy, I had to do some digging to find this one. So these commercial drives have a ton of settings that your typical import drive isn't going to have. We're using voltage input B as our potentiometer. There's also a voltage input A, so you could have 2 different sources for the speed control, okay? And they generally will add together, okay? So I went to parameter F202. F202, this is the voltage input A, which we're not using, 0.1 frequency, which would be at 0 voltage. The default value is 0, but what I found, it's set for 10. So even with nothing connected to that terminal, it wants to go to 10 hertz. So let's change that. We're going to set that back to 0 where it belongs for the default setting. Okay, enter. Okay, and then the one that we're using voltage input B. Okay, reference 0.1. Let's see where that's set. That's parameter 210. 210. Okay, it's set for 0. Okay. Okay, and that's what we're going to do. We're going to leave it at 0. We already have a minimum frequency setting as a base setting of the drive. Well, you know what? Let's just go ahead and change that. Let's change it to 4. Yeah, I got to go back. I'm in the wrong parameter. There we go, enter. Let's change it to 4 because that's our current minimum speed. Okay. Okay, let's start it up. Okay, let's try increasing our speed. So now we're at the same minimum we had before. Okay, that looks like it's working. I'm going to put it to 0. I can change it on the fly here just to see if it's any different. Okay. Almost identical. I think I'll just leave it at the default of 0. Okay. We got our speed pot working. Let's ramp it up a little bit. Everybody's in frame here. Let's make sure. Let's see what happens when we hit the jog button while it's running. Nothing. Okay. How about the e-stop? Well, that still works. And then hit the stop button here. There we go. Okay. Let's try our jog button again. Okay. Now, let's say we've got our speed preset at a high value. So we're in forward. Ooh, let's go there. Save our ears. Okay, I'm going to turn off the drive. Okay. Now let's try our jog button. So the jog button is fixed at that 4 hertz that we programmed in earlier. Very nice. One other thing we might try is not dynamic braking, but magnetic braking. Can't use dynamic braking without a braking resistor, but we can use magnetic braking. Let me see if I can find that setting. All right, I had to go to the computer. I went through the entire manual, looking at the PDF, and there is no option to change the method of stopping the drive for normal stop. It just ramps to stop, whatever the deacceleration time is set for. Okay, but I did find a couple other things that we want to change. So on our emergency stop, we can select coast to stop, stopping after deacceleration, or stopping by emergency DC braking. And that's the one we want, because when we're in an emergency stop situation, we want it to stop. Okay, so let's change that. That's function code 603. Let's go to that one. They also give you an option for adjusting how many seconds that injection time lasts. And what that does, it magnetizes the motor one phase only, and it doesn't tell us what percentage of power it's using, so I'm thinking it's probably using its full power output. So you don't want to do that very long. So we'll leave it at 1 second. Okay. And then here's something else to note. There's a motor protection overload percentage. These older drives, they didn't have a parameter section where you matched the motor nameplate data to the drive. So in this case, we've got a 7.5 horsepower drive with a 1 horsepower motor. So our overload protection is thinking that we've got a 7.5 horse motor. So what we would have to do is find out what the percentage difference is. What would that be, like 14%, something like that? And we'd have to lower our motor overload protection level from 100% down to 14% or 15%, something like that. Okay, probably won't run into that on a newer drive. Hold on, there's one more thing I wanted to show you. Here's another real important one for us, auto restart. Okay, so by default it's no, okay, which is, or 0, that's what we want. But you want to check this because you can have it restart after an instantaneous power failure or a short-term power failure, or both an instantaneous and a short-term power failure. We do not want the drive to restart if we get a power outage or a power glitch. So let's go to that one. That's 301. It's set for number 1 right now, so it's set for auto restart. Okay, we don't want that. So let's put that, oops, I'll get back to it and do it the right way. There we go. Let's set that for 0, enter. So this is a relatively important one for machine tools, okay. Automatic torque boost, okay. Most VFDs are out of the box or set up for a variable torque load, like a fan or a pump, where it doesn't take much power to turn it at low speed. So the automatic torque boost usually works pretty good. It also has options for vector control. I'm not an expert on vector control, but I believe when you're in vector control, no matter what speed you're running at, the drive will put out all the power it needs to try to keep the motor at that requested speed. So essentially your motor could be running very slow, barely turning, and it could still be using the full 1 horsepower or whatever the horsepower rating is. And you need a motor that's designed to do that with extra cooling, or like an external cooling fan, or a lot of mass where it can handle running at full power at such a low speed, okay? And in this case, with a mismatched, it would probably be really bad because it's thinking it's got a 7.5 horse motor, okay? But the automatic torque boost is usually fine because it only puts in the extra voltage that it needs. So let's go to that one. That's AU2. Right now it's at 0, and we're going to change that to 1. Enter. Let's run it one more time, and we'll see how the braking works on emergency stop. Okay, let's hit our E-stop. That was fast. I like that. Okay, let's run that one more time. Yeah, we'll get up to speed. Hit our E-stop. Now, if you've got a screw-on chuck on a lathe, that could be bad, okay? So keep that in mind, all right? You may want to not use that feature. I don't use that on my old South Bend because it's got a screw-on chuck. Okay, all right, well, I think that pretty much covers how to hook up all these remote devices to a drive. I think what we'll do is we're going to go to the newer drive and see what the differences are there. I'm not sure how long this video is getting, so we may break this up into 2 videos, okay? And then if we have time, maybe I'll do a bonus video or bonus extra credit at the end on some other settings and some other wiring issues, mainly with the high voltage part of it. Okay, all right. Thanks, guys. So now we're looking at the Danfoss drive, and I've already hooked up our high voltage wires. What's nice about these is they use plugs. So here's our incoming power, and these plugs are keyed so you can't put them in the wrong location. Then we have a similar plug down here for the motor terminals or motor output. We got our ground hooked up. I already jumped ahead and hooked up our forward and reverse start-stop switch. So let's take a look at what we have there. Okay, so here's our layout. Okay, so down here we have a description of what all the terminals are. Well, let's go back over here for a second. So these are laid out really nice. So this entire terminal block is digital. So these are digital inputs and outputs, start, stop, that kind of thing. Our e-stop will end up hooking up here in our jog. Some of these can also be used as outputs. Okay, this terminal block up here is all for analog values. So that would be our speed pot or remote voltage signal, what have you, to change the speed. This one is for communications. This is a serial RS-485, and then we have a USB for your laptop computer. Okay, so we're working right now on this block, and that's these terminals here. Oh, I forgot to mention these guys. So you also get two conventional type relays, Form C dry contact, and these can be configured for multiple purposes. It comes by default. This one is alarm, and I believe this one is motor running. Okay, and then they give you this nice layout, kind of showing you how the I/O format is connected internally to the drive, so you can get, it's a quick reference for you. I mean, obviously it doesn't show you everything, but it gives you an idea what type of input or output you're working with here, including your high voltage connections. And we're using 18 for forward and 19 for reverse. So let's take a look at the book here. Terminal 18 is start. Okay, terminal 19 has no operation, so we're going to have to program that. So let's go do that right now. Okay, I'm probably going to go through these pretty fast, but just wanted to give you an idea what these commercial drives are like. They use a clear language display, and they're very easy to navigate. We've got a quick menu and a main menu. Let's go to the quick menu first. Okay. So you've got several sub-menus to choose from, and what's nice is they've got a quick setup, so we can go into there, and here's where you can select your language. It's got about 20 different languages. We've got it set for English currently, and I'm just using the up and down arrows. I've already gone through and set the motor horsepower, but we're set for 1 horsepower motor. I've matched our motor voltage, 230 volt, and our frequency, nameplate frequency of the motor, and our motor current, our RPM, and then they've got a check rotation function. We're going to skip that for right now. Okay, and then you've got your acceleration, they call it ramp, excuse me. Ramp up time, I've got it set for 6 seconds. Ramp down time, 6 seconds. Motor speed, low limit. Let's change this one because I don't like 0 as being a low limit. Let's change that. I've just hit the OK button. Lets me edit. We're going to change that to 4 hertz. Okay, enter. Boom. All right, changed. What's nice about this, most of the time you don't even need the book because everything is in clear language here. High limit, speed 60 hertz. Okay, very good. And here's our jog speed, 4 hertz. Okay. Terminal 27. Okay, right now we have nothing on terminal 27. We're going to come back to that. I don't want to enable anything there yet until we actually connect something. Well, let's go back for a second. That's probably going to be our emergency stop, by the way. Okay, so we went all the way around. Okay, so now I'm going to go back. Okay, function setup, let's go in there. We got our general settings, we can go into there. We've got advanced motor settings. We've got analog output. It's got a built-in clock. We can change the clock settings. We're going to skip that. We can change what we want to see on the display here. We're going to skip that for now. And that, we went all the way around, so let's go back. Okay. Open loop settings. Let's use that one. So open loop is a remote control signal that is not based on any type of feedback, and that's what we're going to be using. Okay, so let's hit that. Okay, digital reference, no, we're not going to use that. We're going to use analog reference. Okay, minimum reference speed 0 hertz. Okay, that's fine. Let's go to the next one. Maximum 60 hertz for maximum reference. Okay, that's fine. Okay, whoops, I hit OK by accident. Okay, next. Terminal 53. This is what we're going to be using for our speed pot. So terminal 53 is right here. It's at a very low threshold voltage, 0.07, basically 0 volts. So we're going to leave that like that. That's fine. And maximum 10 volts. That's fine. Okay. At the minimum voltage, it will be at 4 hertz. At the maximum, it'll be at 60 hertz, and that's going to be our speed pot, okay? And we went all the way around, so I'm going to go back. And back one more time. Okay. We're not using closed loop. Let's look at application settings real quick. So we can set this up to control a fan, a pump, or a compressor. We're going to skip all those. We're not going to go into those since we're not controlling one of those. Okay, so that was everything in the functions. Let's go back. We can also look at what changes have been made since factory default. That's kind of a handy thing if you're having trouble. There's some logs, like alarm logs and that kind of stuff. All right, let's not go there. All right, so let's go back. Okay, and then there is a main menu, which is the whole bailiwick. Okay. We want to, while we're in here, we want to look at inputs and outputs, digital inputs and outputs. So we're going to select that one. Digital I/O mode. This is just for a couple of the terminals. 27 is configured as an input. It can be configured also as an output. Let's skip that. And same thing with terminal 29. It can be configured as an input or an output. Okay. So let's go back. Digital inputs, this is where we're going to change this terminal 19, okay? So terminal 18 right now is set up as a start function, which would be forward is default, okay? Terminal 19, okay, start reversing. I already went in and changed that. So I've changed terminal 19 to be start in the reverse direction, okay? All right, and let's leave it at that and test it. Let's go back to status. Okay. Okay, now something that's different about this drive is you can have a hand operation and an auto operation. So in hand operation, I'm going to go to hand right now. We can actually start the motor, and it takes it a few seconds here. There we go. From the keypad, all right? And we can also stop it from the keypad. Okay. You have to be in the auto mode to use remote control. Okay, so now we're in auto mode, and let's see what happens here. Let's go to forward. And there we go. I don't like that delay. We might be able to do something about that. Okay. And then let's try reverse. Okay. All right. So we got our switch working. All right. Off camera, I'm going to see if I can figure out how to get rid of that delay. I was able to get that delay adjusted, so now we're starting right away. They always send out a little test current before the motor actually starts. I'll have to see if there's a way to adjust that. Okay, and then I also hooked up our e-stop, and that was our terminal 27, and I programmed it for magnetic braking for stop, emergency stop. Now I think it's going to reset on its own though. That I don't like. I might see if I can find a different setting, but there's our e-stop. Alright, well the jog was really easy, and it was just to connecting it between common and terminal 29, and we had already programmed that for jog and set our minimum speed or our jog speed at 4 Hertz. So that's working good. Yeah, I don't like that test hesitation kind of start feature that it's got. Let's see if I can get rid of that. But let's hook up our potentiometer first, and then we'll see if we can get rid of that setting. And it's up here, there's terminal 53. Right above it, we'll see that it's got a built-in 10-volt DC power supply on terminal 50. Okay, so that's going to be our voltage source. And then we need a ground, which is right here, common 55. It goes back to the negative side of that power supply. Okay, so if we zoom in on our terminal block, so black was our common, it's on number 55, which is our common. Green is our voltage source, it's on number 50. Okay, and then our return variable DC signal is going in on 53. All right, okay, let me back you guys up. There we go. It's already working. There we go. And our minimum. Okay. Okay, out of curiosity, let's see what happens if we hit the jog button while it's running. Okay, so it goes down to the jog speed. Okay, that's how the other one works on the south bend also. If you hold the jog while it's running, it'll drop it to whatever the jog speed is. And then our e-stop, make sure that's still working. Oh yeah. This is the setting that was screwing up our starting function and giving us that little jerky action. So the flying start, it was enabled, and I've changed it to disable. So let's try it again. Okay, let's give it a shot. Yeah, there we go. That's better. What that flying start does, it sends out a test voltage to the motor so that it can try to figure out if the machine is already spinning to try to match the speed when it goes into a startup. Thought I'd show you this. So you even have a real-time graphing function in the display here. That was frequency. You can look at motor current. Our speed reference. Change it a little bit here. Input power, kilowatts. Not much happening there. Probably frequency is going to give us our best graph right now. Kind of cool. Yeah, this is kind of cool also. So I changed our display so that we can actually see motor RPM. And when we're in forward, it works as expected. When we go to reverse, we get negative RPM. That was kind of cool. And you can see we get our motor amperage is up here at the top, and our kilowatt consumption, or actual kilowatt draw. All right, guys. Well, congratulations if you made it this far. Hopefully that wasn't too boring. And I hope it helped out somebody or you found it useful. So, yeah, that was quite a long video. And if you got questions, I'm not sure if I can answer everything, but go ahead and leave them in the comments. Maybe I can help somebody out. Yeah, and then thanks again. And if you think I earned it, please hit that thumbs up button. All right, guys, we will see you next time. Thanks.